Read the question. All of you, please make a habit of reading question. The best thing is read question and understand the situation given. It'll be much easier. This is spring relaxed. Or x equal to 0, I'll write it is enough. We have a block here. So it is given initial speed v naught. We'll mark the points A, this is B, this is D, this is C. And the surface which is rough, we will shade it. This part is rough and the remaining part is smooth. How spring force and the friction force when they're acting, what to do with the numericals? Because what is the friction force? Non-conservative. Whatever spring force is a conservative. What we can do with this one? So when it reaches at B, this surface is smooth. Read the question. Part AB of the track is frictionless and part BC has quotient of static and kinetic frictions. BC complete, everything is rough. Now when it arrives at B, the kinetic energy of the block will remain as it is. There won't be change in it. Now what will happen? The moment it lands onto the rough surface, friction will start acting on it. No longer it will not have velocity v1 or say some v1. So here the friction will act here. Normal contact. Wait. So what this friction force will do? It will make the block to undergo retardation. So by the time it reaches here, it will have some velocity. Is asking the total distance through which the block moves before it comes to rest completely is given by the value of k is something is asking. I think spring constant, we will get confused. I'll write alpha. Find alpha. Okay, because k is what we use for spring constant or kinetic energy, let's make alpha. A very good problem for all the students who are trying to learn the concept. So what is the state of the block? This I'll remove all this one. So where the block is now, the block has reached one end of the spring. It has reached. What is the state of the it will have some velocity, so that will call it as v1. What are the other forces acting? The friction will be acting and the spring is still relaxed here. We have to calculate this v1. How to calculate that v1? Apply work energy theorem. Can we apply conservation of mechanism? No, friction is a non-conservative force, so we should not apply conservation of mechanical energy. So let's apply the work energy theorem. Kb plus work done by normal contact, work done by weight, work done by friction is equal to kd. Initial kinetic energy mv naught square by 2, 0, this will be 0. Work done by friction will be minus f into what is the distance bd equal to this is what needed. Let's have kd like this, we'll write it. Mass of the block 0.5, 3 square by 2, friction mu mg what friction will act? Kinetic friction will act, no? 0.2, 0.5, 10. BD is how much? 2.14. So 9 by 4, 2 5 are 10, 10, this will be 2.14 into kd. Chetana, please try to understand question, ma. First, I'm explaining something. Please understand it. Huh? Okay, somebody should give me the value of kd.
0.11.
0.11 joule. Okay, well, good. Then, after getting this kinetic energy at kd, now what will happen? As it starts moving, it is having some kinetic energy, so therefore definitely it will go and compress the spring. So as it starts compressing, spring force also will act towards left. So what we see is like now along with this, what are the other forces acting is friction, spring force, all will be acting. Now, so what are the forces that will be acting? Friction, spring force, normal contact, and mg. Okay, these are the various forces that are acting, and because of this, the block will undergo retardation. Definitely, it will have some velocity, say v, and finally, what will happen to the block? The block will undergo retardation, and finally, what should happen? It should come to instantaneous rest. We'll see further what will happen after coming to instantaneous rest. The block has finally come to instantaneous rest. I don't know will it further move or not. I'll call instantaneous rest. The same thing as usual, normal contact, mg. So this is a total compression, no? What is the compression? This xm is the total compression. So how much of spring force now? Kxm will act here. Let's see that. Shall we calculate that Kxm? How to calculate here? Spring force acting, friction force acting. Can we apply conservation of mechanical energy? From D to this is E, I'll call it. Can we apply conservation of mechanical energy between point D and D? The answer is no. Any reason for that? Because friction is a non-conductive force. We cannot apply conservation of mechanical energy. Then what is the best thing? The work energy theorem, which is applicable in all the cases. So no, kinetic energy at D plus work done by friction, work done by spring force, work done by normal contact, work done by weight, and finally it will come to rest. We know instantaneous rest. Kinetic energy at D, we know it, 0.11. Work done by friction, mu mg into xm. Work done by spring force. So work done by spring force. How do we write? Actually, spring force into dx. This is 0 to xm because a variable force, no? Work done by normal contact 0, and finally it will be 0. Mu mg, this will be 1. This everything will become xm. Kx dx 0 to xm. Solving this quadratic equation, I'll get xm. Now mu mg value will be, everything will become 0.2. I'll write down otherwise. So many terms. Let me write in order this, because there's a very important step. 0.1 mu is how much? 0.2, 0.5, 10 xm solving all this will get the value of xm. Somebody should give me the value. After getting xm, we can take a decision on what will happen. When both conservative, non-conservative acting, what we do, we just take help of work energy theorem, because that is a universal, no, applicable in all situations. When conservation of mechanical energy, only conservative forces doing work. I think this is what student has to develop this institution. That's all. The methodology is what you should learn here. What will be the type of question now? Anybody? Quadratic equation? If you can give me answer, then I'll go for the next part.
0.1, sir.
0.1, huh?
0.1, yes.
No. What will happen to block? Will it further move? Total distance moved by the block. Okay, now will it further move? It all depends upon, is it kxm greater than friction? No. What is the static friction? Yes, we have static friction 0.022. So we have to check for that one. So here I'll bring like this. We'll calculate the static friction now. So what is the static limiting friction? How much it is? Limiting friction will be FL equal to mu s mg. Mu s is 0.22, 0.5 into 10. Anybody value limiting friction?
1.1.
1.1 Newton. Let's calculate spring force, how much it is. K value is 2. 2 into 0.1. XM value, check it somebody. XM value somebody has to verify. .2 only? Okay, fine, yeah. XM 0.1. KXM. Okay, fine. Okay, I think almost most of you give this one. Look at now. What is the value of limiting friction? 1.1 Newton. But what is the spring force? 0.2 Newton. So the 0.2 Newton, can it overcome that 1.1 Newton? Not possible. So what do we expect now? The friction will adjust itself to 0.2 Newton. So what is this friction? Not FL. Here KXM less than FL. So what happened to block? Block will not move. The block will not move further at T. Once it arrives at T, it will be there only, because it has come to instant rest. Now the block, the spring force will act towards left. The block wants to move, but the spring force is less than limiting friction. So therefore the block will not shift. Block will not move at T. The block will not move further at E. This is a basic idea. The reason for that, because kxm is less than limiting friction. So what is the total distance it has covered? AB plus BD plus xm. AB is how much? 2, 2.14. What is xm? 0.1. So this will be 2, 4.24 meter. So what is the value of alpha? Alpha should be 1. Just only bringing an idea that if a conservative, non-conservative both are acting, what to do? Take help of conservation of mechanical energy.
Sir, work energy theorem.
So sorry, work energy theorem. Take help of work energy theorem. We'll have one more. Some see once again I wanted to make students to apply the concepts here. Conservation of mechanics. What is use of this? Let's take one